Hi everyone, welcome back to Dr. Tutor. Today we're going to continue Chemistry Unit 3 for QCE, and we're going to do topic 1, and we're going to do pH scale. So the first thing we are going to learn about here is something called the self-ionization of water, which is basically when it ionizes itself. And what this means is basically that sometimes H2O, water, right, will randomly break itself into H plus and OH minus ions. And then these H plus and OH minus ions also sometimes randomly turn back into H2O. It gives us a little equilibrium reaction that looks like this. So we get two H2O, and they somehow similarly turn into H3O plus and OH minus. And this is all aqueous. Basically, again, just a reminder, this H3O plus basically just means H plus, but it's written like that to balance the equation. Therefore, based on this equilibrium reaction, we can actually figure out a QCE, right? We can figure out an equilibrium law expression, and therefore also an equilibrium constant. But since water is a special guy, and the CEO of chemistry really likes water, they decided to give it a special QCE, which is called KW, but it's basically the same thing. Since, remember, KC is products over reactants, this is also the same thing, where the products in this case are H3O plus and OH minus. And now we would have water as a reactant down here, but remember we don't include liquids. So actually the equilibrium law expression is just this. And there we go. And since this is a really important number, this already actually has a value assigned to it, which is 1.00 times 10 to the negative 14 moles. And you might be wondering, why does it have a unit? KC is not supposed to have a unit, but it's because in this case we don't have it like getting cancelled out by anything else down here. We actually just have a concentration times a concentration, so it's still a concentration because the units haven't been cancelled out through the division. And so it actually does have a unit, and this is specifically at 25 degrees Celsius, so like, a normal temperature. Okay, so what we can deduce from this formula is actually that since, just based on this part, right, we then know that also at 25 degrees Celsius, the concentration of this is equal to the concentration of this is equal to 1.00 times 10 to the negative 7. And we know that because we're just doing like some simple algebra. Why do we know that these two concentrations are actually equal though? That is because for every water molecule that is dissociating into H plus and OH minus, so like literally imagine every single H2O, which looks like this, right? Every single one of these has to turn into one of these and one of these. So the concentration of these two are always going to be equal since, every molecule makes one of these and one of these, unless you have added in extra H plus or extra OH minus. But if it's just water, then the concentration will always be equal, and it'll always be equal specifically to 1 times 10 to the negative 7. Okay, and another interesting thing to note is that this is an endothermic reaction. So the forward reaction here is endothermic, which means that Kw increases at higher temperatures, okay, with temperature increase. Okay, so Kw increases with temperature increase. Okay, so the next thing we're going to talk about is the actual pH scale, which is basically just a way of measuring the hydrogen ion concentration. And like literally that's what it is. So the equation to calculate pH is pH is equal to negative log base 10 of the concentration of H plus ions. So it's directly related to it, right? In fact, it's the only variable that influences pH. So first thing to note is that it's a logarithmic scale, which means that it doesn't increase in a linear fashion. It's not like pH 1 is a certain amount, like more or less than pH 2, right? Like, for example, a solution with a pH of 3 would be 10 times more acidic than a solution with a pH of 4. So it's like a 10x difference from 4 down to 3, right? So this is a 10x difference. And then, if you go down to 2, right, then that's a 100x difference. So that's what we mean when we say it's a logarithmic scale, is that it's not just like it increases or decreases by the same amount each time. It's like multiplied. So the further you go away from neutral, the more significantly different it gets each time as well. That's why we have log 10 here. That's kind of what that means, is that every time you get 10 times more acidic or 10 times less acidic, right? Whenever you go up or down 1 pH level. For this formula as well, you can technically you don't need to use H+, you can use H3 or plus as well. I don't remember which one it says on the formula sheet, but it's basically the same thing, because H+ rarely exists by itself. It apparently immediately binds to like a H2O molecule, and so that's why we can just use the same thing, but it's not that deep. You can just use the same thing. POH, I don't know if you've heard of that before, but POH is basically exactly the same thing, but for bases. So instead of measuring H+ concentration, it actually measures OH- concentration. So POH is just like fake opposite pH, kind of. I don't know why they made it up. It's kind of unnecessary, but whatever. If we think about the mathematical relationships between all these different things, right? The first thing we have to know is like, what actually is the point of our pH scale? And that is basically that if you have a pH of 7, then it's neutral. And if you go up, you can go up to a pH of 14, which is basic. Or like anything less than 7 is acidic. So 7 is neutral, anything more than that is basic, anything less than that is acidic. And then the other things that we need to keep in mind is these formulas that I've written here. And since these formulas are true, that also means we can deduce opposite formulas, right? For example, if pH is equal to negative log H+, that means that if you're trying to figure out the concentration of H+, that is equal to 10 to the negative pH. These formulas are not in your formula sheet, so you might want to either remember these or just know how they work, right? And when I say know how they work, I mean just like, this is literally just the opposite of this equation, but if you don't do methods or if you're uncomfortable like having to rearrange this stuff, then you can just memorize these and it'll just do the same exact thing. So this is what you would need to use most of the time. When they give you questions like this, the mathematical relationships they would be asked to consider is you'd have to figure something out. They would give you one of these things, so they would give you the concentration of H+, or the concentration of OH-, or the pH, or the POH, and they would ask you to figure out something else from this like group of things. So they would give you any one or two of them, and then they would ask you to figure out a different one, right? And the way that you can do that is just by using like this set of equations. There is one more super helpful equation though that I would recommend, which is to know that pH plus POH always has to equal 14. And that's really good if they give you like the H+ concentration, for example, and they ask you to figure out the POH. Because as you can tell, between these, there's no formula that like converts from H+ to POH. You could figure it out by using KW and like using these known values and stuff, but you don't have to because you can just remember this. So say if they give you that, right? If they give you this and then they ask you to figure this out, right? Then what you would do is you would use this formula to figure out the pH. So you substitute in this value into here, figure out the pH, and then substitute this pH into here, and then use that to figure out the POH. So it's very good. This equation, definitely remember it. Very important. So just to finish up, we'll go through an example question. So say if you're being asked to calculate the concentration of H+ for a pH of like 8.37, let's say. Okay, what we're going to do is we know that, and I'm doing this so that I can show you how we rearrange this formula into this formula. That's the reason why I'm showing you this, okay? But like, if you want to, you could just remember this, but it's kind of annoying, so it's kind of good to know how to rearrange it yourself as well. So pH equals negative log H+ concentration. That's just like the simple way of writing it. These two equations, by the way, they are in your formula sheet, so you don't need to memorize those. So if you have that, right, let's say you just look at your formula sheet and you get this down, what you can do is you can rearrange the equation by yourself, okay? So you got negative pH equals log H+, this is log 10, by the way, and then what you can do is you can like undo this log, which is something that you should learn in methods if you don't know it. If you do methods, I'll probably teach you about it. If you don't do methods, if you're doing general, I don't think this is in the general syllabus, so then probably just memorize these equations. That's probably way easier. So then basically you just do this, and then that gives you this. And that's exactly what we had before. And so based on that, you can do 10 to the negative 8.37, and that's just something you can type into your calculator, and then that'll give you the answer, which is 4.0 times 10 to the negative 9, and then don't forget your units. Very important. Okay, sweet. Hopefully that all makes sense. If you have any questions, feel free to leave them in the comments down below. And if you want a full copy of these notes, then see the link in the description, or you can buy an active ATAR membership, which gives you access to all of our educational resources for all subjects, as well as thousands of practice questions with answer explanations. And if you want to get any tutoring sessions or assignment help, you can find that in the link in the description as well. But thank you for watching, and like, comment, subscribe, and send this to your friends if you want them to get good grades in chemistry.